Hi guys, morning.
Hey, David.
Hello, David. Hello, Tony.
How is everyone doing?
Yeah, doing well. How are you?
Friday.
Good.
Mm.
Yeah,
Yeah.
finally, almost done with the week. 1 week closer to retirement. Do you guys hear me okay?
Yep.
I'm sorry. Yeah.
Okay.
Yep.
Then that was a pretty flat joke. I wasn't sure if you didn't hear it or if it was flat.
So you're retiring tomorrow?
No, in a few hundred weeks.
Yeah.
I think I have 600 or 700 weeks left to go. Okay. So Tony, I was Michael. Last time we were talking, there is a little bit of hiccup on our side, right? We're supposed to do some designs and stuff like that, but I haven't been able to find the resources to actually do that. We were pretty slammed, and wanted to pick your brain, what you think, how we can move forward on this one.
Be a little more specific.
We were gonna redo all the CPUs with UCAE, HBM2 interfaces, refloor plan the whole thing, add some service stuff like that.
Have we done any functional simulations to date?
No, we don't have anybody to actually do that. So Sigmund started that work. He delivered a setup, and I think it was also synthesized netlist with NAND 45 library for the RISC-V core. But no simulation, no implementation for the core. The reflow planning for the CPU itself hasn't been done. That's where we are.
Yeah. So the CPU benchmark we have is named OpenPython, but we have a RTL, but we don't have a System C version of OpenPython. So that's why, yeah, this simulation is not done. Yeah. I guess.
Yeah. I think that at one point we were thinking about running the RTL simulation, whatever benchmark they have. But again, that requires a time and somebody to sit down and simulate that.
Yeah.
And you generated the if I remember correctly, you synthesized a netlist, correct?
Yes, with
Yeah.
45 NAND. Yeah.
Yeah. Okay.
And so do you have timing constraints for that?
I haven't done the PNR yet, so if I complete the PNR flow, then yeah, we can get the timing constraint.
Oh, you need timing constraints to synthesize first, right? And then the constraints are used for SDA checks.
Oh yeah.
So is it a timing optimized synthesis or just a structural functional synthesis?
Just synthesize with just standard cells. So there's no, we cannot extract the constraint from that synthesis results.
Do you remember? Did you have to specify any clocks when you were doing synthesis, things like that?
Yeah,
I-
yeah, yeah. I specify the clock and some IOs, but I haven't applied the constraints on that.
But okay, so if
Yeah.
you specify clocks, that typically is what you feed into synthesis, and it will use that to synthesize your netlist, right? Okay.
Oh, yeah, yeah.
Okay, so sounds like we have some basic timing constraints.
Do we have a block diagram or anything of what the current version is?
We do. The current version. Okay, let me pull up. Let me open the folder. See the slide deck we have. Okay. And yeah, this is what we have in terms of a block diagram. We need to change this to HBM2. Oops.
So are
let
you
me
using
copy
the HBM model that I sent you guys?
Not yet. Right, we kind of stuck. So this is this. Why is this not going up?
Tony, are you talking about the generic HBM models or an alternate HBM model?
No, I'm talking about a functional model. Verilog model.
Okay, sorry, fair enough.
Yeah, Tony, we haven't used those because we need the rest of the stuff to stitch together.
Well, the issue with the model is you need a controller, and I don't think we have a controller.
Yeah, that's the other thing. And once we get the controller, we need to hook it up to the rest of the stuff.
So
UCAE,
what?
we don't have UCAE models.
Yeah, I know that. So what are we doing for the UCA? Is that just wires that are coming out to the?
Well, for UCAE we haven't done anything. What we had done is bowl. In full bowl, we just had wires coming out.
Okay. And what's coming out to a data bus?
Yeah.
Yeah, in order to see what we can do with this, if we don't have any finer granularity of what's inside the box, the NOC and the CPU.
We only have the CPU. We have inside the CPU, we have finer granularity. The only thing we are missing there is maybe PNR, and right, it's actually two parallel things, right, which are somewhat independent. One is actual simulation, whether it's a benchmark or something, it doesn't matter, but some simulation. And the other one is PNR. So
the CPU is
let me capture maybe why don't I capture
16 cores.
right now it's one core that we can replicate, right? That's the kind of the
All right, so
overall idea.
So you have one core sitting in an empty vacuum, right? It's just a standalone block.
Yeah.
And you're, as I recall, you were just planning to run code on each of those CPUs to create activity on the cores, right?
Yes.
And maybe we can, have some data coming out through the UCI, but it's not really doing anything.
Actually, sorry, yeah. Sigmund, if I remember, the knob was inside the Ariane CPU already.
Yes. Yeah, we can configure to CPU to have CPU to have an NOC inside the CPU. Yeah.
Okay, the knob inside this. Okay.
But the issue, I did look into this a little bit. The issue is that we don't have PDKs for the NAND 40 process.
Can you elaborate on that? What do you mean PDK is not there?
You need all the technology files in order to run place and route. They don't exist for the Siemens place and route tool. I believe, I don't know if Synopsys or Cadence has those. I believe Cadence does, not sure about Synopsys. Says, Sigmund, do you have access to those PDKs?
Oh, yes, of course. Yeah. I have both version, Synopsys and Cadence version of Nengate 45. And yeah, we can do the PNR with those technology files. Yeah.
Okay.
Yeah, there should be enough PDK. What it doesn't have for sure is a prepared Siemens PDK, but it should have the basis for preparing that PDK. It has the technology left. It has standard cell left def.
Mhm.
CDX.
Yeah, that's there's quite a bit of effort
That doesn't
in creating those PDKs. And that's a resource.
Right.
You know, that is
Yes.
man months, several man months worth of work.
Oh shit. Yeah.
Now, if we use
Oh.
something like a TSMC process, we could do it, but then it's not open source.
Yeah.
I don't know, and I don't believe we support the what is it? Company based in Florida. Pertusha, the Skywater guys. I don't think we have any design kits for Skywater. I think that's 128.
130.
130. Can't hear you, Pratyush.
Tony, I did not say anything. Sorry, but are you talking about Skywater 130? The company in Florida, you're asking, right?
Talking about the Skywater 130 libraries. I don't believe Aprisa supports those.
And whatever open source they have, I don't think they have compiled even for Synopsys and Cadence. I'm not sure if they have those compiled and ready to go as open source. Maybe closed source somewhere, yes, but the open source stuff is or maybe they do. Let me take a look.
Pratyush, can you check with maybe Andrew or what the team to see what design kits are available for the Skywater process?
Okay.
Your microphone's flashing, but we're not hearing anything.
No, I did not say anything. I said, yeah, I will do it, Tony. Yes, Skywater.
Okay, thanks.
Let's see. What I see in the Skywater PDK, I don't see anything that says I'm looking to the contents of that right now. They have Spice models, and then they have A layout, Magic, NetGen, NGSpice, OpenLane, QFlow, Xcircuit, and Xchem. This is schematic support. That's what's in the open source kit.
Right, and I think those are open source place and route tools, right? That they're using.
Yeah.
Okay. Yeah, I'm almost 100% certain we don't have design kits for placement. So I'd say if we're gonna run place and route, it would have to be Sigmund using the Cadence tools, or we could ask somebody from Cadence and or Synopsys to build it.
Yeah, let me
So if we can get a layout, we can run our power level tools and run thermal with detailed power models for the layout. So that might be interesting.
Oh,
But
actually, yeah,
without
actually,
the design kits, we're not going to be able to help out on the place and route.
there's for NAND 45 there's a Virtuoso PDK, but it's fairly old PDK, so there's a little bit of question whether the latest version of Virtuoso will beat that PDK at all.
David, I tried PNR with Nengate 45 recently, and it works.
Oh, really? Okay.
Yeah, yeah.
So I'm
in-
looking at the Skywater PDK online, and it does have all the primitives. What are we missing? I mean, we'll definitely have to add design rules for Aprisa to work, or whatever tool we are using, but the basic technology rule files and things are available.
Yeah.
Can you
Yeah,
share? Can you share what you're looking at?
Yeah. Let me know when you see my screen.
Yeah,
Yes,
we
I can
see it.
see you. Yeah.
Yeah. So this is Sky 130 PDK. We have the design rule section. We have, we can go and dig deeper as we need. PDK
Oh,
content I was looking at.
so we do have caliber, I see. Okay.
That's, yeah, LVS deck supported, ERC deck.
Cell
but
generators. What kind
these are not caliber, right? The DSC deck and the LVS deck
I know.
are yeah.
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 But in terms of, where was I? In terms of library, I'm looking at not design rules, but I want to look at libraries. Yeah. In terms of libraries, they have all the digital library, the IO and periphery library as well.
Yes.
Let's see what that is. Okay, I'm not going into the content there. But yeah, I wanted to look at the design, the reference criteria. We'll have to look through it and see what is missing, but it looks like a complete set of design kit at a first glance.
Well, I mean, we need to know what tools they're supporting. So if they
I
have,
mean, they say with Cadence Innovus with Open Road. Let's see what
so
does
it's Open Road, Cadence and Open Road.
Cadence and Open Road, yes. Oh, it's a to-do Open Road. Okay, it's not there. With Cadence Innovus, it's all to-do here. It's only links, but it doesn't show anything.
You know, if we're gonna do a true open source demo, maybe Open Road is a good set of tools to use. Because you're not going to get, it's going to be very challenging to get any EDA companies to develop these design kits.
Yeah, nothing exists here. Only the basic PDK contents exist, but the flows are not there.
So I think we should take an action just to talk to the Open Road guys just to see if they have it. I was under the impression that they have tools that work with this. I know there's universities using it.
That or the Memgate 45, since we have already synthesized with that.
Whatever. If
Yep.
we, yeah, you know, so again, if we want to have a demo that, you know, anybody can run and post it, you know, we can't really have commercial tools. So if we have the open source tools, you know, we're really not trying to demonstrate place around. But the other thing we could do is take some of the design rules. Well, no. Do they have an interposer? Skywater? Or NAM 45? I guess NAM 45.
No, no.
They won't likely.
Yeah. I would think Skywater has it, no? I mean, they do interposers. And so if we're going to do this, somebody needs to take ownership of it. So, you know, we've been talking in circles. So anybody willing to sign up and do a little research to see if what's out there?
Yeah, I'll take a look at that. Yeah.
Okay.
Yeah.
You know, check within Georgia Tech, but I mean, you could reach out to the, you know, the UCLA guys or UC San Diego. You know, there's even NC State, I know, has done some stuff.
Mhm. So, you're curious about whether we can use this PDK as an open source or not, right?
Yeah, so
Okay.
I think I would probably start with the open with the what's the name again? Pertush of the Open Door.
Open roads. Open roads.
Yeah.
Open Roads.
Mhm.
So I think is that under Andrew? The Open
That's the precision innovation work. Yes,
Yeah, yeah,
Andrew is connected to that.
yeah. It's from ABK Group. Yeah.
And you know, I think Andreas also is using that stuff. I mean, we could ping him as well, but you know, I'd say unless we can get, you know, a set of usable PDK kits, you know, we're just spinning our reels.
Okay. Understood. Yeah.
Mhm.
So, Pratish, maybe you could do some introductions to provide some contacts to Sangam, and he can.
Sure. Sungmin, can you just drop me an email so I have your email ID?
Oh, yeah, sure.
Yeah.
I'll let you know my email address on the chat. Yeah.
Yeah. And maybe what would also help just to kickstart the conversation with Andrew and team is if you can give a background of what you're doing there, very short description, and then also what you have currently NAN 40 in terms of NAN 45, let's say.
Mhm. Okay, sure. Yeah,
Yeah.
I'll send it after.
Yeah, but I mean, we
yeah.
could readily resynthesize this into a new technology, right?
Yeah.
Yeah, of course,
We
yeah.
just have the open source RISC-V
Mhm.
RTL. Okay.
Sure.
And Tony, your intent is to use Open Roads tools also for this demo purpose in that case, right? Once we go there.
Say again?
Your intent is to use Open Roads EDA tools as well.
I think so.
Okay.
You know, this way, if people want to, you know, run these test cases and you know, what are we trying to do here? We're trying to demonstrate the 3DKs, right? And what else? I mean, it is that really is kind of the yeah, we're also trying to demonstrate some of these you know, 3DAC workflows that we talked about in our white paper. You know, we've done thermal through power, so there's interesting things we could do. I'm not sure how much we could do with open
Roads.
roads, thanks, but you know, at least if we have a simple little test case with the design kits and the IP, people can start playing around with it and seeing what this looks like. I think there's value in doing that. We would need an interposer PDK, and that's probably pretty straightforward. I would think that's, you're just dealing with routing, but you would need, I know Skywater does interposers, so we might be able to use their design rules. We're not building this, so maybe we use a Skywater PDK for an interposer if it exists. Because all we need is the routing rules and rules to place TSVs. So there's lots of cool stuff. Once we have the layout, we can do power integrity analysis. We can do, finer grain thermal analysis. We could do, we could do signal integrity analysis if we have the buffers. I mean, we are doing that today, predictably, but by having a layout, we could demonstrate something. We can hack something up for the IP. But I think, guys, we need to make a decision. I mean, we really haven't, in my opinion, haven't made much progress in the last 2 years on this. So we need to decide, are we going to continue with this or pull the plug? Thoughts?
Yeah, or do a different version of this, something that we can actually accomplish.
Yeah, the challenge is the IP and the design kits. That's the real challenge with this stuff. Open source. We have some open source RTL, which is great, but you need the physical design kits. Otherwise, you're just working at functional level and predictive. And there's only so much we could do in that space.
Yeah, agreed.
So I think before we put a lot more time into this, let's focus.
So Tony, I have a question to ask you. That do you and possibly to non-Siemens people here, right? Do you guys see the definition of rule names, the definition of the configuration of how a rule is implemented? Do you define that scope as IP, or do you define the scope of the rule values that you apply to a rule as IP?
The IP that I'm talking about is the physical IP, and the models to build a physical design.
So a model to build a physical design, a model component could be a HBM2 model, and that could be one of the components to build a design. Isn't the design?
We actually have the HBM collateral, so we have that. The only thing we don't have are we have all the collateral that Micron provides to their customers, so that we have. What we don't have. Okay, so you need some soft IP, RTL IP, for a controller, and those are non-trivial.
Okay, but couldn't that type of IP be still standardized in terms of the format that it is communicated in, and when the data is transferred in that format,
this is stuff that's inside the chiplet, so this is out of the scope of what we're trying to do in OCP. So this is all stuff we need to build a chiplet. It's the guts, the stuff that goes inside. The 3DAC stuff that we're trying to demonstrate is the stuff that connects to the chiplets and connects the chiplets together and goes outside through the package. So, we do have material properties, but, have we used those for anything? Did we create MDKs for this, David?
Um, I
think-
believe James used them to create an example for the MDK.
I'm sorry?
Yeah.
I'm having a hard time hearing you.
James used them to create the examples for the MDK.
For MDK.
But now,
So-
Tony, what we need to do is to make sure all of those are in JEP30 format and
Well,
make those available to you.
Yeah, I mean, that's fine, but what are we gonna do with it? So if we have the material properties, we need to, something to run the analysis on, right? So if we're gonna run SI, we're gonna need a physical database that uses those material properties to do SI or thermal analysis. So David, you're using those material properties in your predictive thermal analysis?
Yes.
Okay. So the idea then was to, carry that through into the next phase of the implementation, moving from the abstract system level models into a logical or physical model. And I think we do have ADKs as well, right? So we have the design rules. Do we hack up an ADK?
We don't have, I don't know where that is, and David, I've been searching for on the site, so maybe you could send me the link to the ADKs so that I can start doing the transfer into the JEP30.
No, I'm talking about creating we have the assembly design rules for this glass interposer process that we got from Sigmund, and we were going to put those into our ADK format. Question is, have we done that?
Give me 1 second to take a look.
Okay.
So there's an example, basically adding those rules based off of the glass rules that Sigmund provided, but I'm not happy with exactly how this looks. So probably it needs to be cleaned up.
Can you just share what we have on the screen?
Oh yeah, sure. Yeah, so
So you have actual values in there. So is this it?
I keep talking while I'm muted. So yeah, this is the wide version of the same description. Let's see, there's
There we go. There's this is the ADK here for the interposer.
yes,
Okay.
looks like it.
Where are you getting that file, David? Can you drop the link into the chat here?
This is in the CDX Workstream, ABK, ABK.
Against what date?
Posted them.
This is the version 1.0.
Yes.
Oh, so this is in the actual ADK document.
Yes.
This is the link I sent yesterday, right? Is it the same?
I'm not sure which link you said, but this is the this is the ABK here.
Yeah, I think. Let me check. I think yeah, let's see. Yeah, yeah. Okay, so this is a spec, so we need to pull that model out and do something with it.
Yeah.
And
Sorry about the back. Apologies about the background noise. I'll try to mute more often.
so Sigmund, you guys did you actually implement that interposer physically?
Yeah. Yeah. In my research, yeah. Yeah.
So you have a PDK for that then, right?
Yes. Yes. For Siemens tools. Yeah.
So we could do for DDs so what do we have? DRC?
DRC.
And extraction?
We only have a design rule, but we in my research, I didn't check the DRC. Just just enter the design rules.
So you have a caliber deck. Do you have a caliber exact extraction deck for this that extracts the parasitics?
Oh yeah, using hyperlinks, yeah, we extract the S parameter using these material properties and
okay. So
yeah.
so we actually do have then a silicon interposer, or in this case it's a glass interposer design kit. So
yeah.
So we have everything we need for that.
Yeah.
Okay.
Okay, so where can we get access to that file?
Well, what are you going to do with that, Michael? I mean,
well, so far I see this in a format that is not compliant with the JEP30, and we just went through a whole quarter of work getting that JEP30 format released.
Yeah.
So now, what I'd like to see is that we start to consume that JEP30 format in the rules, and so we have to start someplace by taking some set of rules and converting it to that JEP30. Because if we don't do that, what was the whole point of standardizing this through JEDEC?
Well, I mean, that's the whole purpose of this design kit. We wanted to do an example using these kits. So, it's in this document, but you're not going to use an XML file. We need a standalone XML file, and we need to do something with it. So I think we could run we could run signal integrity analysis, right? Just between the looking at the routing channel is implemented in the interposers, so we could run the extractions and create an S parameter for the interposers, and we could look at we have an HBM memory. What we don't have is an HBM5, but we can hack something up. Really just a simple buffer, and we should be able to do some SI on the channel you know, so I'm not as concerned about the transceivers and the IBIS models. I mean, it's really running. The idea is running, you know, the spice analysis on those interfaces, and you know, we're using the MDKs for that signal integrity analysis, so we can demonstrate the MDK in the 80K. So that's something it sounds like we could do today in theory. So I think while, you know, perhaps while we're searching around for these open source chiplet PDKs, we should be able to run that analysis that I just talked about on this design. So Segment, have you used the SI hyperlinks tools?
Yes, yeah. I'm mainly using that tool in my research. Yeah.
Okay. I think there's value there, right? And you know, that's demonstrating 80K and MDK.
Sounds good. Yeah.
Okay, so that way we're actually showing something. David, you already did a predictive thermal analysis. And you're using the MDK for those parameters
Um,
for your material properties for the analysis.
I have to see if I'm using the exact those exact values or not.
So based on what we have today, I think we can, you know, actually demonstrate using an MDK for thermal and SI and an ADK to do a glass interposer. So those are 3 formats where we could actually show something. And how does that sound? Does that sound like a good use of our time? So the idea is we want to flesh out the format, the usage model, before we actually go through and push it through a standard. So I think this would be a good exercise to do. I think to do anything meaningful in power, you know, we're going to need some physical designs. So you know, that's going to take more time. But let's
Do we have
Yeah.
a list of all the material property values against the identity of the material?
we do.
I thought we were just putting in just random examples, but we did we properly identify the material that was going into this?
Well, this is. Did you guys physically build this segment, or was this more of a demonstration, or was it actually manufactured?
Yeah, it is developed by Georgia Tech PRC, and yeah, all these values are from manufacturing paper in the PRC.
Yeah. So yeah. But my question is, did you actually build this, or this was just the paper, and you ran you built the database and ran the simulations, but did you physically build a chip and run and analyze it?
No, we don't. Yeah.
Yeah. So in
Yeah.
that case, whatever materials properties, it doesn't really matter. It's just, you know, it is a paper design process, right? It's not a real process. It's you know, we create it models, and we're just using those models. I mean, we don't want to give away proprietary data for a process, but this is an example that we're using the MDK format to describe those rules, and then we're doing some interposer layout, and we could check that physically to make sure that the interposer that you did, was that routed by hand, or did you use a place and route tool, or what tool was used for that?
CMX Expedition.
So you use Expedition. Okay.
Yeah.
Okay. And are you exporting GDS or ODB++?
ODB++, yeah.
Okay. And you have a caliber check to do the physical DRC, correct?
Actually, I haven't done that the DRC check, but yeah, we can go through that. Yeah.
Well, you could also use hyperlinks DRC, right? If you use XPD, presumably you captured the rules and hyperlinks around hyperlinks DRC.
Yeah.
Okay.
Yeah, caliber can't be ODB++.
Yeah, I mean,
We are all waiting for the day that's going to happen, but it's still not happening.
yeah, I mean, we could create GDS. We have utilities to do that, but without having a caliber PDK, you're not going to be able to do much. You're not going to be able to extract or check physicals. But so we'll just keep it within the package domain tools. Okay, I think we're just about wrapping up. So are we in agreement on next steps?
Yeah, I think it makes sense.
Okay.
Sounds good. Yeah.
So Sigmund, we can provide support for you if you need help on the SI flows and hyperlinks. If you need it, just let us know. You can contact me or Bertush, and we've got a resource on our team that can help you out.
Thank you. I appreciate that. Yeah.
Yeah. So just let us know. And I think it would be helpful to have these actual models. I think putting them in a document is nice, but we really need a model that's being used in the flow. And once we get that kind of the kinks worked out where it's working, then we can distribute those and have that in our little 3DK design kit for this design.
Okay. Sounds great. Yeah.
And then you also work with Bertush to see if we can get some open roads, access to those tools and design kits to see what's available for open source design kits for those PDKs.
Of course. Yeah. Sure.
Okay. Anybody else?
No, sounds good.
All right. Thanks, everyone.
Yeah, thank you.
Thank you.
Happy Friday.
All right.
Happy Friday. Yeah.
Hey, Michael.
Hey, Troy.
do you think it would be a good idea if we just take internal Siemens people to try and take a set of rules and put it into the JEP 30 and see if we can get that format established? I'm going through the document that David shows,
Sure, absolutely.
and it's to me is just riddled with incompleteness. So very difficult to say how exactly you would apply it, how you would standardize on it.
Yeah.
And I think there's just an awful lot of problems with it.
Okay.
So
that would be greatly appreciated. You have somebody that could do that?
Right now, Justin is out on paternity leave, and I haven't heard from him in 2 weeks. So I don't know how long he's going to be taken off. He indicated that he's entitled to 8 weeks, but he also indicated that he wants to come back and do